Let me define the coordinate axis system. X. I'm going to apply a force. F is equal to minus 4 I cap plus 6 k cap. So I'll write here a force F equal to minus 4 I cap plus 6 k cap is acting on block of mass m is equal to 2 kg as shown. The surface is rough with mu 0.3 kg. The surface between block and vertical wall is rough with mu 0.3. We have to calculate find the frictional force acting on the block. Even the direction also is asking us to mention. You don't think this is something very easier. You take some box rather than notebook, no, little bit some box, you take it, press against a wall. There are two forces are acting. Tell me, what is that minus 4 I cap? It will act, I'll be pressing it, no, I'll give the two diagrams, at least. See, it's a three-dimensional. Whenever three-dimensional comes, it'll be very difficult to draw the three-dimensional. What you should do, you have to convert into plane diagram again. So convert this problem into two parts. Try to observe this from two planes. One, let the diagram be in XY plane. If the diagram is in XY plane, so this will be the X component of force. So what is F bar? F bar is minus Fx plus Fz k cap, no? This force, can I also write it in another way? F equal to minus 4 I cap plus 6 k cap. Can we write it as this will be quite easy for you. Then what are other things what all we can notice here? Weight mg, there will be normal contact nx, this will be nx. So don't go for friction, you just wait for friction here. This is the thing. So now I had to show that fz also, no, to show that fz. So you do one thing, take block like this. Let in yz plane, let the block, what is this diagram? The first diagram, block in xz plane. So in, sorry, xy plane. Similarly, let this like a diagram yz plane. In yz plane, so this will be the background will be wall. So either in any plane or plane, the weight mg will be acting along y-axis. Tell me like where that force Fz here to show. So here, sir, what are the coordinate axis? How the coordinate axis? I'm telling this is the this will be the y-axis. Yeah. This will be the xy plane, huh? What you are seeing, that one. No, yz plane. So which will be y-axis? The above is y-axis, and this will be z-axis. Will I agree this? It will be so mg should act along negative y-axis according to this one. Mg should act along negative y-axis. Tell me where that Fz force, the z component of force, should be here, no? Sir, Fx, Fz in same direction. No, I think you have to be very careful. How the friction will act here. Tell me here, what is x-axis? X-axis will be out of the plane. Here, Fx will be into the plane. I'll be pressing this Fx here. What is the duty of Fx? Fx will provide normal contact. So we will determine now the direction of friction. Whenever three-dimensional comes, you have to convert into plane diagrams. So make that problem into two parts. No, because of Fz and only mgx, how friction should act? Friction should act vertically down. Only Fz friction should act along positive axis. Because of Fz and mg, the friction will take direction like this. Background will be wall. There'll be a wall. That wall I'm not showing it. Somebody is asking, sir, where is the wall? This will be the wall. How many of you have patience to really draw such diagrams? So why I'm suggesting like this is, why I'm forcing you, because tomorrow you are going to become engineer, and what you have knowledge, if you don't express, you'll not become successful. So therefore it's your duty to put it in such a way that anybody sees, no, they should understand. Otherwise, you are a good thinker, but you don't know how to express knowledge, so you'll not become successful engineer. So these are the problems what the students nowadays they're facing. They have good knowledge, but they're not successful. They have good knowledge, but they are not successful. The reason is the presentation. Let me take this is theta. Okay, fine. Okay, let's come for that one. Find the frictional force acting on the block. I'll assume that block will be at rest. Let's check it. I'll assume that block will be at rest. Now, we will provide the normal contact. We will provide the normal contact. The fx equal to, so I'll write down all the equations. So this will be nx minus fx equal to 0. So what is the normal contact? What is the fx value? 4 Newton. So nx equal to 4. Then how much of frictional force? What is the maximum limiting friction? Maximum limiting friction should be mu nl, no? Mu nx. What is the value of mu? Mu we are given 0.3. N equal to how much? 1.2 Newton. I'll change this value a little bit. Let me make higher value. All of you just notice here, I just changed the value. 10 I made it. So that some concept you can understand clearly. So this will be how much? 3 Newton. I made the value of fx equal to 10. Just I made some changes here also. Okay, let's come for this one. This is the limiting friction, we got it. I'm asking you, find the friction force acting. Tell me, like, what is this friction force? One component will balance Fz. You must see the diagram after drawing this much only. If you ask it, still I'm helpless. You should have that minimum knowledge of 3D geometry.
Sir, on solving, we'll not get the answers, sir. I mean, mass won't
Wait.
be.
I changed the value of Fx, no, 10 Newton I made it. F sine theta should be equal to mg. The component of friction, this will balance mg. So now F should be equal to, I'll square and add up this. Fz square equal to mg square. What is Fz? 6 square. What is the value of m? Mass of the block 2 kg. So this will be 20 square. So 20.4 Newton I'm getting. But how much the friction, that is, it is greater than FL, no? Tell me what should do now. Block will be at rest or will slide. It will slide along the wall. Block, in fact, block slides along the wall. It will start sliding because friction force, what will happen? Here, how much maximum permitted? 3 Newton only. But how much we are getting? So something value like this. So this is not permitted. This is not permitted. So therefore, open the block, in fact, is going to slide here. So what is the value of friction? It will adjust itself to 3 Newton. So what is the conclusion will you make it? Friction force will be 20.4 Newton or it will be 3 Newton? It will be 3 Newton only. Anybody wants to clarify?
So, but then direction?
You come for that. Mg is how much? 20 Newton. Mg is 20 Newton. Then what is Fz? Fz is how much? 6 Newton. So the resultant of this force, how do it act, that you have to calculate. Then opposite to that, this limiting friction will act it. This is the only cross check what we assume. We assume that, okay, this one I got the friction force acting in this much. So after this, what I should do? The resultant of mg and fz I should calculate. Opposite to that is what the limiting friction will be acting. I think problem is not over. I have to come like this. This will be the weight mg and this is fz, no? So the resultant force will be how it will be somewhere in this direction. I'll make this alpha. What is F external now? F external should be equal to, what are the axes, no? These are the y and z, minus y and z. So F external should be equal to z axis, yeah, minus mg j cap plus fz k cap. Mg will be how much? 20 j cap. Fz is how much? 10. 6 Newton. So calculate that angle. Okay, fine. So how to calculate tan alpha? Tan alpha should be equal to mg by fz. Mg will be 20 by 6. This will be 10 by 3. This will be the alpha. Opposite to this is what I should show the direction of friction. And how much it will act? Fl. Got the idea, no? So in fact, it is sliding and it will have acceleration in this direction. Got this? So this little bit three-dimensional, you have to be careful. So that mg and f2, the effective, that is what I'm showing it here. Where is the wall? There's a wall. The background is the wall. So how to calculate that acceleration now? Acceleration will be f external minus fl by m. Do calculation. I'll move to the next concept. One more is there. Okay, fine, all of you. So the three-dimensional, you have to make that problem into two parts. In each plane, show the forces, then you get a basic picture. Just I think instead of all this, you just take some box, press against the wall, apply one force perpendicular to wall, other force parallel to the wall. So how is Fx? So if I make it things little bit easier, no, Fx, how it will act? Perpendicular to wall. Tell me how Fz will act. Parallel to wall. Finish, sure, nothing big. Go the idea? So let's take now on the situation. There are two blocks are there. Till now what happened, vertical wall, I kept only one block. So let me keep two blocks. I'll apply a force